Hello everyone. Welcome to our talk on effective governance, how Intuit scales schema stewardship with automation. I am Ramapalaniappan, a principal engineer at Intuit's API management platform.
Hi, I'm Alex. I'm a senior software engineer at Intuit. So imagine you're a developer and you're about to build a GraphQL API from scratch. You fire up your IDE and suddenly questions start popping up. Can I use an enum to represent a status? Should I go with a 3-letter or 2-letter country code? How do I paginate my data? Do I really need the relay spec if I don't have infinite items? What about naming? Should I use Pascal case, camel case, snake case? Without a solid structure or standards, we're kind of like this guy standing here. The whole GraphQL landscape is vast and complex. It can feel like a confusing maze. You end up spending increased time and effort trying to figure out all these basics, stitching together a functional schema. The end result, inconsistent, mismatched schemas that causes delays, errors, and a lot of headaches. Now imagine the same developer, but this time they have a clear guidelines and an automated system in place. From the start, they're following well-defined GraphQL schema standards. Automated checks give immediate feedback, catching issues early on. This means APIs are consistent and reliable, developed in much less time with far less stress. The workflow becomes streamlined, letting developers focus on innovation rather than constant troubleshooting. With this setup, every API meets the highest standards, creating a productive and collaborative environment. In today's presentation, we will talk about exactly how we empower this kind of transformation at Intuit. So for the agenda for today, we'll be talking about 1, an overview of GraphQL stewardship. Here we will cover the essentials, ingredients for a successful stewardship program and an inside scoop of how it looks like at Intuit. 2, bots versus brains, striking the right balance. So we have automation to cover stewardship, but where does human invention still required? 3, integration in action, how it all comes together. We'll go through an example of what a supergraph onboarding workflow looks like at Intuit.
Scaling success. So before I go in here, there are 2 words that people use often here, govern and stewardship. So the meaning for govern is like, there are multiple ones. I would like to use this one to control, direct, or strongly influence someone's actions. Stewardship is job of supervising or taking care of something. So at Intuit, we believe we would want to influence and control how a GraphQL schema is authored, used, and we would also like to have a dedicated community around it to take care of it. Okay. The key ingredients of our stewardship principles are governance and documentation. So here, we would want to craft clear guidelines, and we want to enforce those guidelines as well. So this would avoid the common pitfalls that every developer has to come get it there. The other thing is managing and evolving. As we add more features to our API, we want those new ones to integrate seamlessly without disrupting any existing functionality. So backward incompatibility is a big thing, so we do care about it. And consistency across our APIs would help developers understand our APIs better, and they could predict how it would work without learning a new API, how things are being done. So consistency is also an important thing while we are evolving it. And empower developers. So we would want to provide developers with the right sets of tools and also make as many things automated and self-serve for them so that they could concentrate on the domain problem that they're trying to solve rather than fixing a platform issue or troubleshooting it. The last one is enhanced collaboration. Collaboration is a key for API development. Aligning teams around the same shared standards will help everyone to go faster, and it minimizes friction as well. So why you're doing certain things, if everyone understands it, it'll be better. So communicate and collaborate. So that's that. So some metrics at Intuit, like how our supergraphs are, how many developers we have. So we have around 8,000 plus developers. I'm not saying all of them are writing GraphQL APIs. Those are the total developers out there. And we have around 1K plus clients using the supergraph, and there are around 60 plus supergraphs. This is within the federation layer. We have previous versions of federations or the supergraphs parts as well. That's not included here. And we have, within the federated layer, we have around like 5K plus types and 26K plus fields. So the first part, as I said, we have to have clear schema standards. The first step I would say is like, define how you would like your ideal schema to be and document it. And don't do this in a silo, like, or one person shouldn't do it. Get as a bigger group across your organization and discuss with the bigger group and align with most of the people on these standards, because that's important. Because if one person sets it, most likely that standard is not going to be followed or enforced. So if you have more people in there, you will get more feedback and you could get those things done. And once you have those standards set, group them into 2 buckets, mandatory and recommendation. And be pragmatic with setting things. Don't set every standard as mandatory. Otherwise, what you would have is all your schemas are not compliant as per your standards. So you can gradually increase your mandatory batch or group more, but start with lower level of mandatory stuff. So that way you could get better compliance. And while you're defining these standards, use existing industry standards. Don't reinvent things. So when I say existing industry standards, it could be like a relay spec for pagination, or ISO or IETF standards for some data types. Use those rather than creating your own, because that it'll be easier for anyone new coming into your organization to comply to these standards as well. Then the next is automation-driven development. Automate as much as possible in the API development lifecycle. At Intuit, we automate a creation of a subgraph microservice itself. So they could just go to a dev portal, and with few clicks, they could get their own subgraph created with a template schema in it that follows all the standards that we talk about. And we also have automation for supergraph onboarding. When a new subgraph is onboarding to a supergraph, it's like we have a certain process for it, automation for it. And we also have a manual approval process in some cases for the first time when someone is onboarding to us. So that's also automated. So similarly, wherever possible, automate. So that way, self-serve helps developers go faster and increases productivity as well. And integrated tooling is the next one. So create tools that are tailored to your use case. Like if you have defined your schemas, you need to identify the right set of linters that could ensure the compliance of the schema to the standards that you have set up. So if existing tools doesn't work for you, then you need to create your own or do something else of that sort. Then the toolings that you have should be in the places, should be integrated wherever the developers are. It could be in IDE, it could be in CI/CD. If required, a CLI could be done. So in those cases, that will help them develop faster. And the continuous improvement is build a community around it. And at Intuit, we have many special interest groups. So we have a dedicated one for API as well. So this group drives certain API-related tracks and also consults on specific issues, including schema authoring-related issues as well.
Yeah, so next we'll talk about bots versus brains, striking the right balance. Now with everything Rama shared, how do we go about striking the right balance between what we can automate and what still requires human intervention? So what should our GraphQL playbook result in? So we want a seamless GraphQL paved road experience and a good supergraph onboarding experience. So we have the 3 core ingredients here. Number 1, self-serve onboarding. So this is actually a developer portal we have created at Intuit. It is a one-stop shop platform that connects all of our core technologies. This includes the provisioning of an entire basic GraphQL service experience, such as having schemas, resolvers, and it's bundled with an initial deployment from Jenkins to Kubernetes with a pre-production environment and a mock playground to play around to explore your APIs. 2, we need automation and tooling. We need a streamlined process to ensure that whatever features we build from our foundational service is automatically vetted with as little turnaround time as possible. 3rd, human review. There's still some steps we're not able to automate, and where are those? We still need human review So let's take a look at the Supergraph onboarding experience today. So it all starts with the subgraph team. So the subgraph team, after they create their initial service, they make their changes, and then they're ready to onboard to the Intuit Supergraph. They initiate the Supergraph onboarding from our developer portal, where they can request a schema review. The schema review is an automated process where it generates a GitHub issue for us, and it goes through a bunch of linter checks automations that generates a report for an API steward to review and also add their comments. So that whole process is now automated, and the whole feedback package is brought back to the subgraph team, where they're able to review, resolve comments, and go back through the iterative process of onboarding to the supergraph and reviewing their schema. Once the schema is ready to be onboarded, an API steward can improve this onboarding process. In the backend, it does a couple of things. Mainly, it adds a stage to the CI/CD pipeline that bundles the API share library for subgraph owners to publish their schema to the supergraph. But in addition, at Intuit, we have contract routers. So contract routers are basically where we have subsets of our schema available to different consumers. So we have an approval step that assigns the specific labels to the schema so they can only be onboarded to those specific variants. So with the generated PR, and once the subgraph customer merges the PR, they're left with a bunch of schema integrity checks in place that ensures that their schema is up to date and are able to publish to the supergraph. So with ongoing changes, they now go through the same flow, the schema integrity checks, before they're able to publish their schema. So talking a little bit more about the schema integrity checks we have, first is choosing the right linter at Intuit. So at Intuit, this journey was almost 2 years ago now. At that time, there are a couple options, ESLint, Apollo Schema Linter. We saw a great demo from Apollo Schema Linter. It's well integrated with the Apollo ecosystem, but there are a couple of things that are missing for us. There are two main things. One of them is we need an extensible way to customize our rule. So for example, we follow some schema design principles such as namespacing for separation of concerns. So how do we enforce subgraph schema types fields that are appropriately namespaced? And another one is custom exceptions. So at Intuit, we deal with TurboTax, a lot of fields and form names and titles that we follow exactly in our types and fields. But those don't necessarily follow the standard GraphQL guidelines and syntaxes. So we need a way to grant exceptions at various granularities, at the subgraph level, the types level, the fields level. So those were the two core problems we had with the existing linter space and why we had to create our own. So with the linter, we wanted an always-on strategy. This means we are shifting left with a real-time feedback in your IDE as a plugin. So this is actually a work in progress. We're still working on this, but it should be available, in the near future. We also have an API bot integrated with GitHub. So when they make a PR, the bot comments on schema issues, and customers can resolve them. Lastly, rigorous checks in CI/CD pipelines. So if it wasn't caught in the IDE and it wasn't caught in the PR and a customer still tries to publish these changes, it's blocked in the CI/CD step as there are still checks within the pipeline in place.
In addition to the schema linter, there are other schema integrity checks that we do, and these are part of the CI/CD pipeline as well as you could run these things separately on your own. So first one is schema auto tagging. So we use Apollo contracts a lot. And if you have used Apollo contracts, it basically is like a subgraph developer can use @tag within their schema and add certain names out there. And there are chances that a subgraph developer may not understand the consequences of this @tag and could add wrong tags in there or delete certain tags from existing schema. All of these would have an impact on what is the actual API schema that the client or the client application sees. So, and we could get incidents on these as well. So what we are doing is, instead of the developer actually adding those tags, so as Alex mentioned in the previous slides, the API steward at the point of reviewing for the first time and they're approving a subgraph to onboard to a supergraph, they also say that, okay, you are going to be on this particular contract. So since we know that information, we use that to tag the schemas just before publishing it. So that way we don't get into this incidents related things. So that's one part. And similarly, like integrity guardrails are like extending the same contract example, right? So the initial ones of like, right now you, by default, when you do a subgraph compose check or schema composition check using Rover, it does the contracts as well. Initially, that was not the case. So make sure all your subgraphs, if you have more than one contract, all your contracts are composable before publishing it. Otherwise, you may break something in prod. So there are cases where these kind of normal GraphQL directives that could potentially have impacts or create incidents. So one other example is at inaccessible. If one subgraph developer just marks one particular thing as at inaccessible, they may impact all other subgraphs that are actually referring that particular type, because the moment any subgraph marks one field or type as inaccessible, it is removed from the API schema that the client is going to see. So there are cases such that those kind of stuff should be handled, and though we give a lot of self-serve for the developers, we have to make sure the guardrails are put in place so that we are not experiencing an incident because of those. And the last one is, all these automations, whatever we do, we need to make sure we are capturing it and having a dashboard for this, so that this dashboard could be used by multiple teams, the platform team like us, or the subgraph team, or even the clients. So this dashboard that you're seeing here is the linter related results. So this is what you're seeing at the top is just a number of errors that the linter has got during that particular period. And you have a trend lines of number of errors and the most common errors that you're seeing here. So you could use these information to actually, like if you see a particular type of error being seen across a lot of teams, you could have an education system or some sort of a brown bag or whatever it is to educate them on how to fix those things. So you could use those insights from these dashboards as well. Okay. The human element, like when a subgraph is trying to join a supergraph, we mandate that the subgraph schema is reviewed by an API steward. So this is in addition to all the automation we saw and the flow that Alex mentioned. So who could be an API steward? We ask domain leaders to nominate one or more API stewards within their domain. And we ask those nominated folks to go through a training that familiarizes them with the standard that we have established. So once they go through them, any new subgraph that is coming from their domain, those API stewards are going to review. So the advantage that they have is now they have known the standards, one, and they also know their domain. So they could use these two in a knowledge to review the schema more effectively. So that's the one that we're seeing. And the example here is one of the reviews that I did for a schema that came in. So there are cases where our linter wouldn't work, especially with language intent and consistency. So this is one of the things that we have in our standards. Like we cannot easily determine that using our linter. And there could be, the domain related stuff may not be, we won't be able to capture it in our linters and other parts. So the human review here would be important. And the way we are trying to do is, we are not asking the API steward to review every change. It's only the first time a subgraph is onboarding to a supergraph, we are forcing the human review. The subsequent changes to the schema, it is optional for the subgraph team to opt in for it and ask for it. Like whenever they see that, okay, there's a big change that they're making, we always recommend them to go through it, but we are not mandating there.
Yeah, so next, how it all comes together. Here we're going to go through a quick demo of the supergraph onboarding process. So the screen you see here is our developer portal at Intuit. When they're ready to onboard to the supergraph, they can go to this GraphQL schema composition tab. Right from the start, we can see we have a bunch of prerequisites they need to satisfy. In this case, there's a namespace registry prerequisite. So subgraph owners are required to register to a namespace and use it in their subgraph. But we do have the schema auto-tagging in place, so they don't actually need to add anything in their schema. So once that prerequisite is satisfied, they can start the process. This kicks off the review process by generating a GitHub issue. So here we see that it generated a supergraph onboarding process. they can go to the affiliated GitHub issue. And here we provide an overview of what their subgraph service does. We automatically assign domain experts to review this. And there's just a couple survey questions they also have to fill out. And at the bottom here is the generated report. It includes the linter summary. Of course, this is a new service, so it's free of errors, warnings, and information. But we provide a linter summary as well as a schema link where the API steward and the subgraph owner can collaborate, reference lines, and talk about the different issues they're trying to resolve. Next, we have integrated documentation. So this documentation shows basically an overview of all the tools, such as linter, that we're integrating in a subgraph owner's pipeline, as well as why different linter severities are categorized the way they are, and each specific rule we're checking, as well as links to how to resolve them. Finally, when the schema is ready to be approved, we add this label. So this label is actually how we determine the right contract router and the variant to publish your schema to, as well as an approval milestone. With these two added to the GitHub issue, there's an automated backend process that will automatically approve this onboarding request. When they refresh the page here in developer portal, we can see that their status is now approved. So what happens after this approval? There's actually a PR generated back to the subgraph owner's GitHub repo. And we can see it added a couple stages. Give it a second. Right, so here we can see that it automatically generated some steps. We call it GraphQL publish, but this actually encapsulates a lot more than just publishing the schema. It encapsulates all the schema integrity checks we talked about for each stage that the subgraph owner wants to publish. And that's the demo.
So here's a recap of what we did. First, define GraphQL standards and align teams around those standards. So that's when you could adopt those standards well. And create automation wherever possible and add enough guardrails, because we don't want the developers to come and talk to us on certain things except for the last API steward review. And that's also which is not the common platform team that they're going to talk to. It's an API steward within their domain is what going to do it. That's the only human integration point or an interaction point that we have in our system. So since we are doing it that way, make sure you have enough guardrails around it so that one subgraph developer accidentally doesn't cause an incident on or impact on other subgraph. Next is foster development enablement. As I said, like make everything self-serve, so that way they could concentrate on their domain problem rather than troubleshooting a platform issue. And recruit a pool of API stewards that you think are ideal to enforce the standards. And this set of API stewards should not be from one group within your company. It should be for the same group that they have picked up for. So that's how it would be effective. And the goal of this whole process is not to ding a subgraph saying that, okay, you don't know how to write a schema. The intention is to create a consistent schema and evolve towards it. You may not be there on the first day, so you may have to grandfather certain other old subgraphs that you have gotten, or you have a lot of teams that are already using it. So you may have to do those pragmatic changes and accept it. And one other thing is, whatever standards that you've set need not be set in stone. Over a period of time, technology changes. There could be other reasons why you would want to change your standard as well. So be open to those things as well. Okay. What next for us? As we said, the human interaction that we have is still a pain point here. Like if a team was actually creating a REST service instead of a GraphQL subgraph, they have full autonomy to do whatever things that they want to do. Right now, if they're creating, just because they're creating a GraphQL subgraph, we are asking a human review to go through the schema and give reviews and say, okay, you can't use this one, this is wrong or that is wrong. So that's a kind of impact or a cultural thing that we are seeing. So what we're trying to do is try to get that early on, like using an AI-driven schema authoring. So basically say, this is my domain, this is what I want to do. Can you create a schema that is compliant with the standards? That's one part. And the AI-assisted review processes, there are things that our linter cannot do now. So we are just thinking if can we bridge that gap with AI. Right now we are not replacing anything. We are still trying to assist in the mode. So that's what we are trying to go next. Okay, that's all we have. Thank you.